Hi everyone. So now we are going to talk about force between two parallel current carrying conductors. Okay. So this idea is very simple. First of all you have to get the idea. That is why I am discussing it. So you have to understand what is exactly what idea we are using here. That the idea which we have already found out or we have already got from the force acting on a current carrying conductor when it is placed in a magnetic field. Look at this. So here one conductor is there. So the force acting on this current carrying conductor when it is placed in a magnetic field, that we know. What is that? I into L cross B. I into L cross B. My question is, suppose there are two current carrying conductors. There are two current carrying conductors. You can check this. So we have to find out the force acting on this current carrying conductor, the blue one, the current carrying conductor, when it is placed in the magnetic field. What is the magnetic field here? This is the magnetic field. Look at this. This will produce, this is a long straight current carrying conductor. This will produce a magnetic field. So this conductor, blue conductor is placed in a magnetic field which produced by the black one. Similarly, the black conductor is placed in a magnetic field which is produced by the blue one. Okay, so I think you have got it. So this will produce a magnetic field, this will produce a magnetic field, both of them will interact each other. That is what is the force. I think you have got it. If you haven't got it, just go back and again play it, then you will understand it again. Okay. So we are going to start the discussion. So there are two long current carrying conductors. First one I1 and I2 and II. Okay. So sorry, 1 and 2. Those are the current. 1 and 2. Those are the conductors. I1 and I2 are the current passing through it. So let's consider. So here both the currents are in the same direction. They are passing in the same direction. It could be in the opposite direction as well. No problem at all. Listen. So first one, B1. What is the magnetic field produced by the first conductor? Magnetic field produced by the first conductor is equal to mu 0 I1 divided by 2 pi r. But the direction is important. Direction is important. Look at this. We are considering in Z direction. Both the conductors are placed in Z direction. Okay, that is K. And I can say that, all of you listen. I can say that here the magnetic field produced by the first conductor, that is this one, in this direction. Okay, that is why I have given the cross sign. That is into the paper. So what about the magnetic field produced by the second conductor? It is outwards. It is outwards to the paper. So this is into the paper, outwards. Alright. So B1 is equal to mu 0 I1 divided by 2 pi r minus I cap. That is this one, minus I cap. Into the paper, minus. Outwards we will take I. IN minus I cap. So like that you can take. Okay. So again, next is B1 again I can write it as minus of mu 0 I1 divided by 2 pi r. Let it be here. First one, DF. That is the magnetic field produced. All of you listen. I'll explain it in a very simple manner. Consider the second one. Consider the second conductor, this one. Then we are going to consider a small current carrying element DL here. Small current carrying element DL. The force acting on this small current carrying element DL due to this first conductor, that is what is DF. So I can write it as I2 into DL cross B1. B1, the magnetic field produced due to first one. So look at this. The magnetic field, the force acting on this conductor will be due to the current the current passing through this conductor under DL and the B1. Because it is placed in a magnetic field where B1, so it is B1 is here, B1 is here. Okay, I told you that is this one, like this. This is the conductor and the magnetic field is due to this one, the black one. Okay. And next is, so I can write dF is equal to this one. Okay. So dF is equal to B, you can substitute the value of B1, mu 0 I1 I2 divided by 2 pi r. I2 is already here, I1 divided by 2 pi r into DL into J. Why it is J? Because it is magnetic field is in the direction of I. Okay. What about dl? dl is in the direction of z. So k cross is I, k cross I is equal to j. Minus sign is still there. Okay. So this is what is dl. What about force? Now we are going to, this is important. The force per unit length of, I think you have got this. Why j? Why in the direction of j? Because field is in the direction of I. dl is in the direction of k. Okay, because I told you in the z direction. Initially only I told you in the z direction only we are considering. So force per unit length of B due to A is equal to F by L is equal to mu 0 I1 I2 divided by 2 pi R in J. This is what is important. So take this dl to the side. Nothing we have done. Okay. So we are considering the complete length, that will be F by L. Next is similarly consider the second one, B2, the magnetic field produced by the second one. B2 is equal to mu 0 I2 divided by 2 pi R I. Why I? Why not minus I? Because this is in the outwards. Okay, so that is why I. So F is equal to I1 into dl cross B2. Okay, mu 0 I1 I2 divided by 2 pi R into dl into J. So force per unit length of A due to B is equal to F by L is equal to minus mu 0 I1 I2 divided by 2 pi R. Why? Because it is I cross K. It is I cross K. It will happen I cross K. That is it. Okay. So this is what is the total idea F by L. So I think you have got it. The force per unit length of B due to A is this one. Force per unit length of A due to B is also equal to this one. So I think you have got it, and this is how we derive it. And one more example. So in this case we have considered both are in the same direction. So if both the currents are in the same direction, which means, so look at this. Here I'm going to find out my thumb rule. By my thumb rule, look at this, current is in the direction. So here magnetic field in this direction, coming outwards. What about here? Here magnetic field into the paper. So magnetic field are in the opposite direction. So this will be attraction. What about here? This will be magnetic field in the opposite direction, where the currents are in the opposite direction. Magnetic field here, it will be outwards. Alright. So here it is outwards. What about here? Here it is also outwards, because current in the opposite direction. Here it is also outwards. So both are in the same direction. So here it will be repulsion. Attraction and repulsion. So next is definition of 1 ampere. So where we will find out the definition of 1 ampere? From this equation or from this equation. Definition of 1 ampere we can find out. So look at this. Here mu 0 by 2 pi is there. Mu 0 by 2 pi. What is the mu 0 value? 4 pi into 10 to the power minus 7 divided by 2 pi. So that is 2 into 10 to the power minus 7. Okay, 2 into 10 to the power minus 7. When I1, I2. When the current passing through the both. What is 1 ampere? 1 ampere is nothing but the definition is given in the textbook very clearly. That is, I'll explain it. Listen, all of you listen. You have to understand that definition. Then there will be a question like this. Okay, so the question would be like this. You have to deduce the equation for force acting, force between two current carrying conductors, and write the definition of 1 ampere. Okay, 1 ampere is defined as the current when passed through each of the two infinitely long parallel conductors. So what is the current passing through both in two conductors? That will be equal to 1 ampere. Okay, so I1 is equal to I2 is equal to 1 ampere. Then F by L is equal to mu 0 by 2 pi. R is equal to 1 meter. Okay, each other and two infinitely long parallel straight conductors kept at a distance of 1 meter. So R is equal to 1 meter. So R is equal to 1 meter. I1 I2 is equal to 1 ampere. Then F by L is equal to mu 0 by 2 pi. Okay. So parallel straight conductors kept at a distance of 1 meter apart in vacuum cause each conductor to experience a force of 2 into 10 to the power minus 7. So why 2 into 10 to the power minus 7? Mu 0 by 2 pi. We know that mu 0 by 4 pi is equal to 10 to the power minus 7. How much will be V0 by 2 pi? Yeah, that is 2 into 10 to the power minus 7 Newton per meter length of the conductor. Okay, so that is the definition of 1 ampere. This is the most important definition of 1 ampere. So it is like, what is 1 ampere? It is a total current passing through the two infinitely long current carrying conductors. So when it is placed at a distance of 1 meter, and the force per unit length acting on each of the conductors will be 2 into 10 to the power minus 7 Newton per meter. Okay. So this is what is all the things about force between two conductors and the direction, I mean attraction, repulsion, and the definition of 1 ampere, etc. And we will continue the discussion. We have to find out the torque acting on the current carrying loop. Okay, when it is placed in a magnetic field. Thank you.